Water is capable of dissolving a variety of different substances, which is why it is such a good solvent. Water is called the universal solvent because it dissolves more substances than any other liquid. Water is capable of doing this because of its polar arrangement of the hydrogen and oxygen atoms. On one side, the hydrogen atoms have a positive electrical charge, and on the other side, the oxygen atom has a negative charge. This allows the water molecule to become attracted to many other different types of molecules. We show this through a food coloring demonstration where we mix blue food coloring with both water and then with oil. The food coloring mixes with the water because of the water's polarity. On the other hand, the oil is nonpolar, so the food coloring does not mix. It sits in clumps in the oil. The unique shape of the water molecule allows water to facilitate chemical reactions and dissolve many substances such as food coloring.
Water as a solvent is important in everyday life because without water as a solvent, our bodies would not be able to perform many of the chemical reactions that take place in our cells. With water being able to dissolve all kinds of molecules, it allows the chemical reactions to occur. For example, water is used to suspend the red blood cells in our bodies to carry oxygen to the cells. Electrolytes and nutrients needed by the cells and the act of carrying waste materials away from the cells in our kidneys use water as their solvent. The ocean is an example of solution with water being the solvent and sodium chloride as the solute. Water dissolves salt when water molecules attract the pull apart the sodium and chloride ions in salt crystals. The ocean is a very important aspect to life on Earth because it supports millions of organisms and allows them to grow and reproduce with its unique properties with the help of water as a solvent.
When table salt, sodium chloride, is mixed into water, H2O, it dissolves and becomes an aqueous solution. This occurs because water is a universal solvent and because sodium chloride is soluble and hydrophilic, meaning that it is able to be dissolved, especially in water. Sodium chloride is composed of one sodium ion and one chlorine ion. The sodium has one electron in its valence shell, so it wants to get rid of it, and chlorine has 7 electrons in its valence shell, so it wants to gain an electron. Because of their compatibility, they have an ionic bond, which means that one electron from the sodium was completely transferred to the chlorine without any sharing of electrons, which leaves the chlorine with a negative charge and the sodium with a positive charge. Water, on the other hand, or H2O, is composed of 2 hydrogens and 1 oxygen. These ions have a polar covalent bond, which means that they have an unequal sharing of electrons, giving the hydrogen a slight positive charge and the oxygen a slight negative charge. Because H2O has a polar covalent bond, the positive hydrogen regions of the water molecules are attracted to chloride anions, and the negative oxygen regions of polar water molecules are attracted to sodium cations. A sphere of water molecules, called a hydration shell, surrounds each solute ion. Working inward from the surface of each salt crystal, water dissolves each salt compound. The result is an aqueous solution of 2 solutes, sodium cations and chloride anions, mixed with water, which is the solvent. The salt compounds essentially dissolved because the water molecules surrounded each of the solute molecules, forming hydrogen bonds with them, which dispersed the solute, resulting in an aqueous product rather than a solid undissolved in water.